Hello and a warm welcome back to my YouTube channel. Thanks very much. Don't forget to smash that subscribe button before we get into this video, which is looking at the relationship between delta G, which is the Gibbs free energy, and E naught for the cell. We can see there's a negative sign there, so delta G is minus NFE naught. Don't forget the minus sign. N refers to the number of electrons. F is Faraday's constant, which is 96485. And E naught you will normally work out from two given standard electrode potentials in the question. Just a quick recap to work out E naught for the cell. It's the reduced minus the oxidized, or it's the cathode, take the anode, or for the spontaneous reaction, I'm sure you do the same as me, look for the most negative E naught value, flip the sign, and add it to the other value. Because the most negative is the one that will oxidize, so you have to reverse it, hence you flip the sign. Okay, so what's the relationship between? We've been looking at delta G, we've been looking at Kc, the equilibrium constant. These things are related together in the following triangle. So at the top we have our Kc value, Kc at equilibrium, where delta G is 0. And we have our E naught value that we can work out from our relative standard electrode potentials. And then relating delta G to E naught, which is the purpose of this video, is delta G is minus NFE naught. We'll see some examples shortly. Let's go and have a look now. So let's take a moment, just explore this relationship that we just introduced at the beginning of this video. I've now included the quantities and their definitions on the left hand side. R is still 8.314. It always has been, it always will be joules per Kelvin per mole. Temperature is always in Kelvin. I can't think of an instance in IB chemistry where you leave it in degrees C, so keep it to Kelvin. Unless it's delta something, like in delta T, then it doesn't matter. N is moles of electrons used. Don't forget, the same electrons go in are the same electrons that come out. And Faraday's constant is just a constant, 96,485. Little table at the bottom, which is looking at the relationship between the E naught values. Clearly E naught has to be positive to give a negative delta G. Negative delta G means it is spontaneous. Don't forget, that doesn't include the kinetic factors with regards to the reaction. When Q is less than K, it goes to the right hand side. Q is more than K, it goes to the left hand side, which we have looked at in a previous video. When Q equals K, there is no overall reaction. Macroscopic properties stay the same. Microscopic properties, of course, are changing. And for delta G to be spontaneous, a spontaneous reaction, E naught must be positive, not forgetting it's minus NFE in the equation. Let's have a look at an example. As with all examples, it's probably wise as a student to have a look at the question. Once you've digested the question and had a look, maybe take a minute to reflect on what the question's actually asking you. That 1 minute spent reflecting on the contents of the question could save you minutes at the other end of the question when you're struggling to work out what it was asking in the first place. I always advise students to take a breath before you actually embark on answering any IB question, particularly calculations, and they do like to be cryptic. So, avoid any red herrings by taking your time. Don't forget 90 seconds per mark. We now have bromide with fluorine. Fluorine's more reactive, so fluorine will end up as the ion. So we've got 2Br- reacting with F2 to make bromine plus 2F-. The question is this a spontaneous process? Clearly, we're going to have to look at more than just saying, yes, it is, because fluorine is more reactive and it will end up as the ion. That used to be enough, no longer is it enough, because now we have to look at the relative E naught values. These are often given in the question, they can be given in the question, or they can ask you to look them up in the table of standard reduction potentials, which are in your data booklet. This is where I got these from. So E naught for bromine, as you can see, don't forget this is adding electrons, so we're gaining, so this reduction is gain, oil rig still holds, is 1.06, and fluorine is 2.87. The one which is most negative, or the least positive is the same thing, is the one that will oxidize. That's going to be the reducing agent. So is bromine going to be the reducing agent? Yes, well, oxidation 1.06. So we can take the difference, flip the sign, it's positive, now it's negative, so we take it away from the 2.87. We end up with an E naught of positive 1.8 volts, which is that 1.81? I think it's 1.81 volts. Yes, it is. And that means it's spontaneous because it has a positive E0 value. Is that enough? No, because the question was find delta G. There's 2 electrons going in of the same electrons which are coming out. It's not 2 new electrons, it's not 4 electrons. It's the same 2 electrons. So N in delta G is minus NFE is 2. F is Faraday's constant, just get it from your data booklet, and E0 you worked out in the previous part of this question. We've got minus 349,276 joules, far too many sig figs, so 349 kilojoules per mole negative is our delta G. Let's have a look at another example. Well done if you got that correct. So very well done if you got the previous answer correct. Let's have a look at a final answer. This one's a bit more tricky, which is why I've included it at the end. Okay, so again, we're going to take our time. We're going to have a look at what the question is actually asking us. Something a little more exotic now. We've found some cobalt. We've got the standard reduction potential here. It's already minus 0.28 volts. And we're going to have to start off by calculating the cell potential. Most negative, flip it. Oh, it's very close. 28 minus 0.76. Okay, what's the most negative? Minus 0.76. I'll not give the answer away. Calculate that in your head now. So we want the standard cell potential, and the question's also asking what's oxidized and what's reduced. I love the word species, that's great. Aliquot's a current favorite at the moment, but that's irrelevant to this video, so let's continue. So calculate E0 and delta G. Great, that fits in with the purposes of this video. So E0, what we're going to do, what's the most negative? The most negative is the minus 0.76, so flip its sign, because the zinc is going to oxidize. It's going to be the reducing agent, isn't it? So that means it's no longer minus 0.76. It's going to be plus 0.76. And if we sum it with the cobalt's reduction, which is minus 0.28, we've written them out now fully as the one that's oxidized and the one that is reduced. Now with the sign changed, hopefully. There we go. Add them together, and we end up with an E0 of... Are you excited? Are you sitting comfortably? 0.48 volts. Very good. It's a positive 0.48 volts. So that means it's going to be a spontaneous reaction when we put it into delta G is minus NFE0. So we can see that the cobalt reduces and the zinc oxidizes. So going back to the question, don't forget to refer back to the question and check you've answered the question. Don't throw away easy marks that you know and are implicit in your answer, but need to be explicit so your examiner can actually see them. Now it's just a simple matter. We've got 2 electrons. We do delta G is minus NFE. N is not 4 electrons. Remember, it's the same 2 electrons. So delta G is minus 2, 96485 times E0, which is 0.48 volts, which is minus 93 kilojoules per mole. Well done. Subscribe.